In this tutorial, we'll explore how object-oriented programming, OOP, can help us build cleaner, more scalable financial applications in Python by modeling financial instruments, portfolios, and transactions as objects. We'll see how OOP makes complex financial systems easier to design and maintain. In object-oriented programming, OOP, a class serves as a blueprint for creating objects. It defines the attributes and behaviors that objects of that class will have. In this example, we create a bank account class to represent a bank account. Each bank account object stores information about the account owner and the current account balance. The init method is a special method known as the constructor. It is automatically called whenever a new bank account object is created. The constructor initializes the object's attributes, such as the account owner's name and the starting balance. By using the constructor, we can create multiple bank accounts with different owners and balances while using the same class definition. The deposit method allows us to add money to the account. When a deposit is made, the specified amount is added to the current balance. This method simulates the real-world action of depositing funds into a bank account. By encapsulating this behavior within the class, we ensure that all balance updates are handled consistently. The withdraw method allows money to be removed from the account. Before subtracting the requested amount, the method checks whether sufficient funds are available. If the withdrawal amount is less than or equal to the current balance, the transaction is completed and the balance is reduced. If there are not enough funds, the withdrawal is rejected. This validation helps maintain the integrity of the account and prevents negative balances. The getBalance method provides a simple way to view the current account balance. Rather than directly accessing the balance attribute, users of the class can call this method to retrieve the account's current value. This approach follows OOP principles by providing controlled access to an object's data. For example, suppose we create a new account for John with an initial balance of $1,000. When the account object is created, the constructor stores John as the owner and 1,000 as the balance. If John deposits $500, the deposit method updates the balance to $1,500. Later, if John withdraws $200, the withdrawal method checks that sufficient funds are available and then reduces the balance to $1,300. Calling the getBalance method at this point would return $1,300. This example demonstrates several important OOP concepts. The bank account class bundles data, owner and balance, together with related behaviors, depositing, withdrawing, and checking the balance. Each bank account object maintains its own state, allowing multiple accounts to exist independently. By organizing code in this way, OOP makes financial applications more structured, reusable, and easier to maintain. As applications grow in complexity, classes provide a powerful way to model real-world financial entities such as bank accounts, investment portfolios, loans, and trading accounts. Inheritance is an important concept in object-oriented programming that allows one class to inherit attributes and methods from another class. This helps reduce code duplication and promotes code reuse. For example, we can create a parent class called financial product that contains common information shared by all financial products, such as the product name, and a method called getInfo to display product details. We can then create child classes such as stock and bond that inherit from financial product. Because these classes inherit from the parent class, they automatically gain access to the getInfo method and any shared attributes. At the same time, each child class can define its own specialized methods. For example, the stock class might include a method to display stock-specific information, while the bond class might include a method to display bond-specific details such as the coupon rate or maturity date. Inheritance allows us to organize financial products into a logical hierarchy. Instead of rewriting the same code for every financial instrument, we define common functionality once in the financial product class and reuse it in the stock and bond classes. This makes financial applications easier to develop, maintain, and extend as new financial products are added. In summary, inheritance is a fundamental concept in object-oriented programming, OOP, that allows a class to inherit attributes and methods from another class. This promotes code reuse, reduces duplication, and helps create a clear hierarchy between related classes. In our example, the financial product class serves as a parent class that contains common properties and methods shared by different financial instruments. The stock and bond classes inherit these features, allowing them to access methods such as GetInfo without having to redefine them. At the same time, each child class can include its own specialized attributes and methods that reflect the unique characteristics of that financial product. For example, a stock may have information related to shares and dividends, while a bond may include details such as coupon rates and maturity dates. By combining shared functionality with product-specific behavior, inheritance makes code more efficient and easier to understand. As financial applications grow and new financial products are introduced, inheritance provides a scalable way to organize and manage code. Developers can build on existing classes rather than starting from scratch, leading to software that is more maintainable, flexible, and easier to extend. Polymorphism is an important concept in object-oriented programming, OOP, that allows different classes to be treated through the same interface, even if they behave differently. In finance, this is especially useful when working with different types of investments such as stocks, real estate, and mutual funds. For example, we can define a general parent class called investment with a method like calculate return. This method represents the idea of calculating profit or return, but the actual implementation will differ depending on the type of investment. We can then create different child classes such as stock investment, real estate investment, and mutual fund investment. Each of these classes inherits from investment but implements its own version of calculate return. For a stock investment, the return might be based on share price changes and dividends. For a real estate investment, the return might include rental income and property value appreciation. For a mutual fund investment, the return could be based on the overall fund performance and management fees. The key idea of polymorphism is that we can use the same method name, calculate return, across all these different investment types, but each one behaves in its own specific way. This allows us to write flexible and scalable code where different financial instruments can be processed using the same interface, making financial applications easier to extend and maintain. Next, we loop through the investments list using a for loop. Inside the loop, we call calculate return on each investment object. Even though the method name is the same for all objects, Python automatically runs the correct version of the method depending on the type of investment. For example, if the object is a stock investment, it calculates return based on changes in share price and dividends. If it is a real estate investment, it calculates return based on rental income and property value appreciation. If it is a mutual fund, it calculates return based on overall fund performance and fees. This demonstrates polymorphism, where the same method name is used for different objects, but each object behaves in its own specific way. It makes the code simpler, more flexible, and easier to extend when new types of investments are added. An inner class, also called a nested class, is a class that is defined inside another class. It is used when one class is closely related to another class and should not be used independently. The inner class helps organize code and logically group related functionality together. In Python, an inner class is defined inside the body of an outer class. The outer class can create and use objects of the inner class, but the inner class is usually not meant to be accessed directly from outside. We define a class called portfolio, and inside it we define an inner class called asset. The asset class represents a single investment, such as a stock or bond. Each asset has a symbol and a quantity. The init method of asset initializes these values when an object is created. The display method prints the quantity and symbol in a readable format. The portfolio class represents the investor's full collection of assets. It has an init method that takes the owner name, for example, John, and initializes an empty list called assets to store all asset objects. The add asset method creates a new asset object using the given symbol and quantity, and then adds it to the portfolio's asset list. The show portfolio method loops through all assets in the list and calls the display method for each one. For example, we create a portfolio for an investor named John by writing something like portfolio equals portfolio John. Then we add multiple assets to it using the add asset method. Each call to add asset adds a new investment to John's portfolio. Finally, when we call show portfolio, The program loops through all stored assets and displays each one along with its quantity. This makes it easy to see exactly what John owns at any moment. This example demonstrates how object-oriented programming helps model real-world financial systems. The asset class represents individual investments, while the portfolio class manages a collection of those investments. Together, they show how OOP allows us to build clean, scalable, and organized financial applications where complex systems like investment portfolios can be represented in a simple and structured way. You've completed a full object-oriented programming (OOP) for finance mini project in Python. You learned how to use classes and objects to model a bank account, apply inheritance for financial products like stocks and bonds, and use polymorphism for different investment types with a common interface. You also built a portfolio system to manage multiple assets and used an inner class to organize assets within a portfolio. Overall, you applied OOP concepts to create a simple but realistic financial system that is clean, reusable, and scalable.